Welcome back to Mrs. Bailey's Math. We are on topic 3.9, inverse trigonometric functions. That's my Johnny. All right. As with all functions, of course we have just. Of course we have. This was the reason I knew I needed to change my sign seat, but it's okay. I'm working on it. Anywho, as with all functions, the inverse of a trigonometric function is the result of switching the input x and output y values of the function. As a result, the output values of the inverse trigonometric function will be an angle measure. We can represent inverse trigonometric functions in two ways. That's the sine inverse or the arc sine. Either way, we'll say arc sine of x, but I say sine inverse, opposite. So write the statement sine of power of 6 equals 1/2 in the equivalent form with arc sine notation. So when we say sine, remember in the parentheses is our what? What's this power of 6? No.
B.
Huh?
B.
No, I'm not.
What are you asking for?
What do you got?
It's our x value which represents what? The angle. Yes.
What?
The angle. The angle's in the parentheses. Jeez.
Right.
We just had a spring break, so please be patient with my class.
Sorry.
No, I'm recording. So this is the angle, y'all. So if I said sine of the angle, sine is the what value?
The Y value?
The y value of power 6 equals 1/2. But if I'm doing the arc sine, that is the arc sine, I would do arc sine of 1/2, which is, I'm going to plug in my y value. I'm trying to find what is the angle when my y value is 1/2. And that is, there you go, power 6. I can either use arc sine or the sine inverse of 1/2, which is the y value. When my y value is 1/2, my angle or x value is pi over 6. Does anyone have any questions on that? I have the unit circle on the other page. Does anyone need to see the unit circle relation? Yeah? All right. So the unit circle, when if I have the arc sine of 1/2, I'm looking for when my y value is 1/2. My y value is 1/2 here at pi over 6. So that is what the arc sine is, I input my y and I output my x. It's the inverse. Besides input my x, output my y, I input my y, output my x. All right? We're doing it in reverse. All right? So we can use sine inverse or arc sine for that. Okay. Any questions on this? All right.
Wait.
Where do you output your X at?
So if I'm trying to, sine is the y value. So usually my x's is my angle. But if I'm using arc sine, my x's is the sine or the y, the x or the y. And then I input my y value to output my angle. All right, restricted domains of inverse trigonometric functions. Because trig functions are periodic, you will see you must restrict the domains to create their corresponding inverse functions. I have to restrict it because we know that it works in a wave. Okay? We need to restrict the domain. So, in order to make the inverse a function, we will restrict the y equals sine of x to the domain of negative pi over 2 to pi over 2. That is why it's highlighted. You would see parts where it restricts the domain. You can only look at that area. Y'all see how that restricts? All right. Similarly, we will restrict our cosine function for the same purposes. However, for y equals cosine of x, we will restrict that domain from 0 to pi. Remember? 0 to pi, x values, angles. For the tangent function, we will restrict the domain of y equals tangent of x to negative pi over 2 and pi over 2. Negative pi over 2 to pi over 2. Due to the vertical asymptote at negative pi over 2 and pi over 2. Important note about inverse trig functions. It is important to always remember and consider domain restrictions when working with inverse trigonometric functions and values. So if I said that we are looking for when the inverse sign of x between the ranges of negative pi over 2 going what direction? Clockwise. And pi over 2 going counterclockwise. We're restricting it to this area of the x where the x values will be, yeah. All right, and the cosine. If we do the cosine is our x. And our x values, positives and negatives, is restricting the domain between 0 and pi. And the tangent is our y over x. And that is restricting the domain between negative pi over 2 clockwise and pi over 2 counterclockwise. All right, so now let's do some work. Yay! Okay, so if we're trying to get the inverse cosine is our what value? Our x value. If we're trying to get the inverse cosine of negative square root 2 over 2, we're going to go to where is our x? Negative square root 2 over 2. The second quadrant, we can only look between 0 and pi for cosine. So the second quadrant, when our x value is negative square root 2 over 2, our angle is in radians, I'm sorry. 3 pi over 4. That's how we're doing it. The inverse of sine. Inverse of sine is using the y values, positive and negative. Now, we're doing the sine inverse of negative square root 3 over 2. Sine is our what value? Our y value. Our y value, when we look at only the quadrant 1 and 4, when our y value is negative square root 3 over 2, what is our angle? Five pi over 3. Okay, excellent. All right. So that is negative 5 pi over 3. I'm sorry, not negative 5 pi over 3, but it's 5 pi over 3. Or we could say negative pi over 3. Because when we're talking about our sine function, we're only going from positive half pi over 2 to negative pi over 2. Negative pi over 2 is when we're going negative angle goes clockwise. So remember in the part above it, it says we're restricting the area. For our sine, we only restrict it to the right side, quadrant 1 and quadrant 2. We need to see when is our y value negative square root 3 over 2. That is here. When we go clockwise, pi over 3, that is negative pi over 3. All right? Think about the restrictions from above. It's up here, the restrictions. Now the tangent is restricted to what quadrants? 1 and 4. This is between negative pi over 2 and pi over 2. So if I'm trying to get the tangent of square root of 3, I need to figure out when does my y over x equals the square root of 3. So when my y over x equals the square root of 3, it's here at pi over 3, and I can show you all by square root 3 over 2 divided by 1/2. We do what? Keep, change, flip, and that would give me, which cancels out the, all right. So when our y over x give us square root of 3, it's at angle or radian. Okay. You know, I try. Ever since you got that blowout. All right. Any questions?
Are you on the first page?
We're working. We're trying. All right. Now for some more fun. Yay. There you go. The angle theta is in standard position. The terminal ray intersects the unit circle at point P, whose coordinates are x, y. The points Q, R, S are the results of the terminal ray being reflected over the y-axis, the origin, and the x-axis respectively. For each of the following expressions, determine which label point intersects the terminal ray of the given angles. So, cosine of x. That means cosine is our what value? Our x value. And what gives us our positive x value? Which variable? Remember, cosine is restricted to what?
The top.
Okay. So what could be the inverse cosine of x? We're going to look between what two? And what two variables is in quadrant 1 and 2? What's in the quadrant 1 and 2 variables? P and Q. So if I'm looking for the inverse or the when my x value is positive, that is where?
The first quadrant.
First quadrant, and that's P. Y'all see what we're doing?
Yeah.
All right. So the inverse of sine. Sine, we only looking at quadrants what?
1 and 4.
1 and 4. When is our so we only going to look at what two variables?
P and S.
P and S. When is our y negative?
S.
There you go. Bada bing, bada boom. Now cosine, the inverse of cosine. Cosine, we only looking at what quadrants? 1 and 2. When is our x negative? All right, and that's his variable Q. Everyone following me?
Bar people.
All right, and then we have our tangent. Inverse tangent of our negative y over x. Tangent, we only look at what quadrants? 1 and 4. So we're going to look at what two variables? P and S. We're looking for when we have a negative y over x. So that would be S.
That's smart.
Wasn't that fun? I know.
I get it.
Now we're going to keep on with the notes. So we can get these over with, and then I can just give y'all delta maths for the party tomorrow. Partay. I mean, no partay. We're not allowed to have partays. So no partay. I'm sure you two won't tell.
If I send out the line,
How many? Line? How many people
You're
are
lying,
playing
you're lying.
No, you said when you have one.
I'm fine. You look like cowboy today.
Rodeo.
Shitty cowboy.
Rodeo.
No, it's too much. I didn't think myself.
I didn't even say anything. You elaborated on it, so. Yeah, I was very surprised that you told me that. I'm glad you feel safe enough to tell me.
That's nuts. No.
Okay, let's not say it, 'cause I don't wanna know.
Bugs and stuff.
This morning,
They gonna fruit flies.
this morning in first block.
This morning at first block, what?
But hold on. Let me pause. And we're back like we never left. Okie dokie. Notes. Topic 3.10, Part 1. Trigonometric equations and inequalities. Consider the following two equation statements. We have the equation of sine of x equals 1/2, and we have the equation of the inverse sine of 1/2 equals x. Are these two equations equivalent?
Maybe.
Yeah, I would think so too. Yeah, because it's inverse of the other. On the unit circle, we know that there are two angles between 0 and 2 pi, where sine of theta equals 1/2 and theta equals pi over 6, and when theta equals 5 pi over 6. However, due to the domain restrictions, remember the domain restrictions on the last notes? I didn't see it. The inverse sine of 1/2 equals pi over 6 only because remember for sine we restrict the domain to what quadrants?
1 and 4.
There you go. Look at Damiana's on it.
You locked in today, aren't you?
I wasn't here yesterday and answered the question.
See, I heard his name on the intercom this morning. I said I know him. I teach him. Okay. Now, as a result, when we are solving equations involving trigonometric functions, we must modify our solutions to account for any domain restrictions or the lack of any domain restrictions. So finding general solutions to trigonometric equations. Since trigonometric functions are periodic, we can have infinitely many solutions to an equation if no domain restriction is given. Let's reconsider equation 1 from above. We know that the sine of x equals 1/2 when x is pi over 6 and when x is 5 pi over 6. However, since sine is periodic with a period of 2 pi, we also know that sine of x equals 1/2 when x equals pi over 6 plus 2 pi, which could be 13 pi over 6, 5 pi over 6 plus 2 pi, which could be 17 pi over 6. All we had to add was a full another rotation. In fact, we could keep rotating around the unit circle as many times as we want to create infinite many angles where sine of x equals 1/2. That's why we restrict the domain. Write the general solutions to trigonometric equations. Sine of x equals 1/2. That is when x equals pi over 6 plus 2 pi k, where k is an integer. Just like that period we did. Y'all remember the periods? Periodic? Okay. Y'all don't remember when we
What we did, what?
when we were trying to find what is the y value at of 31, and I have the period of 5.
Oh, yeah, isn't
Oh.
that where we, like, guessed?
Yes.
Okay, yeah. So it was like that thing that said, like, the Y of 31, you had to.
Yeah. How many periods? Well, we know that in sine there is 2 pi periods. So 2 pi of how many periods plus the pi over 6, or 2 pi times how many periods plus the 5 pi over 6. For cosine, we're talking about pi over 3 or 5 pi over 3 added to the 2 pi, which is a period. And for tangent, we know that our period is not 2 pi, but our period is, for tangent, what's our period? Pi.
Yeah, I said that.
Yeah, I know. So we did the pi over 4 plus the, Jesus, I told you don't bring that phone in the, okay, well, it's okay, we're working on that. Oh, okay. We do pi over 4 plus pi periods, pi over 4, and you know the k is how many periods, since the period of tangent is pi. Alrighty. So example 1, let's do some problems, some fun stuff, yay. We're working on it. All right. Find all the solutions to the equations cosine of negative square root 2 over 2. Cosine is my what function value? My x. So when is my x negative square root 2 over 2? I'm not restricting domain at this point in time. No restrictions. Only between 0 and 2 pi meant.
So only in the first and second quadrant?
No, this is with no restrictions right now.
Oh, and the next is.
So I guess.
But this is with no
It's either in 3.
So is it 3 pi over? Yeah, 4.
3 pi over 4 plus a full period of
No clue what that means.
what's 2 pi.
I'll cook, Chuck.
That's what we just did.
I did it too. Teamwork.
2 pi k. Y'all.
Explain.
All right. So when is our x value negative square root 2 over 2? Our x value
3 pi over 4.
Yeah.
is negative square root 2 over 2, 3 pi over 4, and
Dork.
5 pi over 4. We are not restricting the domain on this one. We're going from 0 to 2 pi. Remember, we usually restrict the domain. Yes.
Oh, Miss Bailey?
Huh?
I looked at the AP class last night. It don't look like nothing.
Don't look like what? Oh, you want to say that on my YouTube?
That's why I was listening.
Oh, okay. Let me pause it because you know how she be trying.
You see, that's why I was listening.
No shade.